No, just my paper. So it's recording right now. I'll pause it when you guys start working. Okay, so this is 9.3 chords and arcs. Go ahead and put your name on it. And in the corner, or period 2, in the corner, you can write like where you're going to put it in your binder. You can write page 2. I would also, I should have told you this earlier, I would grab some highlighters. So if you want to go and grab some highlighters real quick. As many as you can. I'm going to get at least 2, I think at most 4. At least 2. Get 3. Get 3. Just in case. I have 4. I don't think we're going to use that many, though. If our paper was bigger, so from now on, I'm going to make sure that the pages aren't like this, where the circles are super tiny. If the circles were bigger, it'd be easier to mark with a highlighter. We're going to mark up the congruent parts, and this should help us a whole bunch. Okay, so a central angle is an angle with its vertex where? Who remembers from last class when we were doing 9-1? Where's the circle? Where's the vertex of the central angle? The center, yeah. So looking at angle B right here, ABC, what are the sides? The 2 sides of the angle would be what? What are those called? AB and BC. Radius, yeah. Radii is the technical name. I like saying radiuses because it's funny. So for an example, angle ABC is a central angle in circle B to the left. I think you all, most of my classes told me this when we were talking about circumference. You told me a degree. Do you know how many total degrees all of these central angles added up would be? 360 degrees is correct. So 84 plus the remainder of the, like Pac-Man, right from Pac-Man, Mrs. Pac-Man, the rest of this circle would be 360 degrees. Okay? So the measure of the arc formed by the endpoints of the central angle is equal to the measure of its central angle. So it's literally equal to the central angle. Whatever that degree is, it's going to be equal. So AC's degree would be how many degrees? What would the measure of that arc be? Yeah, 84. But then going around the arc to the other side, Jackson's going to ask to come back into the classroom. I think, maybe? He's taking his test outside. Yeah, I think he has a question. We would subtract it from what? 360. Yeah. Minus 84. Can we let him in? Huh? 276? I agree. What's up? Okay. Do we agree that we take 360 and we subtract it by the angle that we do have to find the remaining of the arc? Okay, cool. So pick 1 through 4 for us to go over together. 1. Okay, sweet. Okay, so what do you think ST would be equal to? Yep, 122. How do we find our S? That arc. Yeah, because RT is your diameter. So there's 180 degrees right there. So 180 minus 122. Is that right? Oh, sorry. I didn't borrow. 58. Yeah, I think so. What's that? What's that sass? Tisking of your tongue. Yeah. Whole number, yeah. Whole number. Okay, and then here's where your highlighters are going to come in handy when you're talking about SRT. Find at what? Okay. Start at S, go to R, and then go all the way to T. How would we do that? That's one way. 122, subtract it from 360. I like that. What's another way? Yep. Add 180 and 58. So whichever way you want to do it, does not matter. That's what I got. 238. Questions on that? Nope. Okay. Pick one on the other side with algebra. So you can pick 8, 9, or 10 that you want to do together. Which one? 8? Okay. You guys are picking the easy ones to do together. I don't mind. 10. Okay. I don't mind doing the easy ones together. Okay. What's the dealio with 10? We want to find x. We want to find all of those arcs. Do we have anything that is equal to each other where I can set them up? I don't see any diameters. So I'm looking for vertical angles. I don't see any vertical angles here. So I think all of those central angles are going to be different. Anything that you notice that stands out? Right angle. Okay, so that means y would be how many degrees? 90. Okay. Not Be careful about that. Add up, not, hey, no. Yeah, what do you include when you're adding them up? What angle? 90, all of the arcs. You cannot exclude the 90. So add up all of the arcs, but I'm going to combine like terms. So do 8 plus 21 plus 10. I got that as well, 39x. And now add the 90 to the negative 12 to the 9. You have to add all of it. What does that get you? 87, okay. Equals, what's the total number of degrees in the circle? Okay, go ahead and solve for x. It is, so we do 90 minus 12 plus 9 to get that. What do you get? 7? Okay. And then you can start plugging in to find the missing pieces. 273, and that divided by 39. Yeah, I got 7 as well. Where do you want to plug it in first? WX first. Okay, 21 times 7 minus 12. Move if you need to move. Guys are playing with a calculator. That's not cool. Okay, I got 135. Okay, cool. And then WY, what do you want to do for WY? You're right. So I was going the wrong way. Thank you, Dia. I was going WXY. And then I realized that should be a minor arc. So WY is really talking about this part. So plug in 8 times 7 to get VW. What's 8 times 7? 6. Okay. And then add it to 90. Yep, 146. And then WX. That one you can plug in, right? So 10 times 7 plus 9. 79. Okay. So I think we have all of the pieces. So 90, 56, 135, and 79. So those are all my pieces to get the arc. This one I'm going to trace with my highlighter. V, X, W. So that's this way. VXW. I started going the other way, clockwise, and then I realized X is in the middle, yeah. So even I make mistakes. I would do 360 minus 56. What's the other way to do that one? $90 plus 79 plus 135. Whichever way you want to do it, you can either subtract or add. What do you get? Beautiful. Okay. Shall we move on? Yeah, okay. We'll come back to this stuff if we need to. We're going to do each part. There are 3 properties of chords. Sometimes they're used all at once. Sometimes they're used one at a time. So the first property of a chord, so remember that your chords are the segments that have 2 endpoints on the circle. 2 endpoints on the circle. 2 chords are congruent if and only if their arcs are congruent. When I talk about their arcs, I'm talking about the arcs that they intercept. So in this case, AB and CD are congruent, so they're equal to each other. You can write congruent or equal. I'm going to say equal to each other. If and only if, so that has the arrow going back and forth. Either way, it's true. Their arcs are congruent. So I don't know if I said that correctly. Those 2 are chords. These 2 are arcs. Okay, so AB is equal to CD, the segments, if and only if the arc AB is equal to the arc CD. Did it break? Not clicking down. Okay, that happens. Okay, pick 1 through or 4 to go over? Or even 5. We can even do 5. Which one? Maybe 5? Because it's the last one. We can do 5. Yeah, 5 would be the hardest. Are you sure you can handle 5? Yeah, we can handle 5. Okay, let's do it. Let's do the hardest one. I don't know if it necessarily is. Okay, the thing that makes this hard, I see that the chords are congruent. So that means ZY, because it intercepts ZY, that arc is congruent to XY. Okay, so I don't have both of those, so I can't set them equal to X, but I can duplicate it. I can copy paste it. So if ZY is 6X minus 20, that means XY is also 6X minus 20. So what do you think we go from here? Yep, that's it. You add them all up and equal it to 360. So we do what? You combine like terms, so you get 12x minus 40 plus 76, I love it, equals, it's the total number of degrees because there's no gap in the arc, so that would be 360. Okay, simplify from there to get x. Keep your hands to yourself. Guys, they're like middle schoolers right now. And then divide by 12. What do you get for x? I got 27. What happened? Oh, did you put negative 40 or did you do positive 40 by accident? Might have been positive 40. And then when you subtract, I think that's what happened. Because you got a smaller number than me. Is that what happened? No. Oh no. That's okay. That's okay. I'm going to come back down to this one later. Huh? How did I get 36? I did negative 40 plus 76 and I got 36. Okay. The other property. The other property is if they are equidistant to the center. Two chords are congruent if and only if they are equidistant to the center. So how do you tell if it's equidistant to the center? You look at the kind of radius type shape right here, EF and EG. If they have a mark like this, that means they are equidistant, and it has to meet at a right angle. Has to meet at a right angle because that is the shortest distance from one point to the other. So AB is equal to CD if and only if EF is equal to EG. Thank you. Can I have the formula sheet, please? Thank you. Can we go over an example first? Okay. Number 6, 7, 7 or 8? Which one would you like to go over? I think they're equal. We can go over both if you want to. Do you want to do both? Okay, 7. Okay, if DE is that, and EF is that, find, or sorry, FG is that, find DE. Okay. They are equidistant to the center. Do you see the little tick marks right there? Okay, so that means the whole segment is equal to the whole segment, just like the arcs are also equal. Remember, for the first property, if the chords are congruent, then their arcs are congruent. So you set them equal to each other. So only if you have the whole thing. Do you have the whole thing, DE and FG? Yep, you have the whole thing. Equal them to each other and solve for x. Is that 21x minus 27? Sorry, I'll let you guys solve. I'm verbalizing my solving. Did you guys get your x? Okay, I got 2. And then DE is the 11 times x plus 15. So that gets us 37, which I think I heard Miguel say. Yeah? 37? Okay, cool. Did we also want to do number 8, or are we feeling okay with this? We're good? Okay. Let's go on to the last thing. The last thing is kind of tricky because the picture's not really great, but we'll go over the picture. Are you okay with drawing a circle? 2 circles? Yeah, okay. There's space over here for us to draw it. So to the best of your ability, let's see if I can do it better than first period. Look at that circle. Does not have to be as good as my circle. It can be better than my circle, but it does not have to be better, as good as my circle. First thing that we're going to draw, if we have a chord, any chord whatsoever, and either the diameter or part of the diameter, so it goes from the center to the chord itself and is perpendicular, guess what it does to the chord? What do you think? What's it going to do to that chord? It cuts it into 2 equal parts. It bisects it. So the diameter, or part of the diameter, bisects the chord, and if it goes all the way through, it also bisects the arc. So that's pretty cool. It like cuts everything in half. It's like you're taking a little slice, and if you slice it perpendicularly, it like splits it in half perfectly. So that's also true if you have 2 chords and they're equidistant to the center. So let's go back to our words at the top. So this is the last thing that we learn about chords. If a diameter or a radius is perpendicular to a chord, then it bisects the chord and its arc. Okay, so it cuts it in half, cuts both pieces in half. So let's take, we're only going to take the top one, AB. So we already see that FE is perpendicular. So AF and FB are equal. And AH and HB are also equal, those arcs. So I'm going to write out all those letters. So the first thing has to be true, and that is that the chord part I'm going to say EF, EH is perpendicular to AB. I had a hard time with that. So EH is that radius. It's perpendicular to the chord. And because that is happening, AF equals FB, and those arcs, AH, is equal to HB. So those are arc marks, not lines. We can do 9, we can do 11. 9, I like it. Here's where highlighters are good. You guys good to move on? Yeah, okay. So for 9, here's where highlighters are good. The segments only deal with the segments, the angles only deal with the angles. Segments only deal with segments. So let's deal with RS and then ignore the fact that we know arc TY. If RS is 18, oh, sorry, I wrote that wrong. I'm treating it like an arc. My bad. RS is the thing right here. So from here to here, RS is 18. What would TV be? Ooh, it's this bit. Is it the whole thing or half? Half, yeah. So 9. So if the whole thing is 18, the radius is perpendicular. So all of this is cut in half. That's it. All of it is cut in half. So it's either going to be, your answer is either going to be 9 or 18. So decide which one it is. TV, I agree, is 9. What about TU? 18. What about WS? Perfect. Okay. Now we're done with 18. We can ignore it. I'm going to switch to a highlighter for the arcs because those are tricky, and I'm going to switch colors. Okay. So I give you TY, that arc measure. This arc measure is 42. Same junk applies. So it's either going to be 42 or double 42 because 42 is the half. Do you see that? Am I making up stuff? Okay, we're good? Okay, so what is UY? 42. And then what would RS be? 84. Very good. Yes. Oh, I'm so sorry. You asked and I completely ignored you. Okay. Do you want to go into a problem that is super tricky, but we do it together? Yeah, okay. Pick one, either 13-14 or 15-16. We're going to do 2 questions. So either the 13 one or the 15 one. 13? Okay. They're equal. They're about the same complexity, so it really doesn't matter. So this is where we're dealing with like the single radius, and it's perpendicular. So that means these two are equal. Yes? That's it? Okay. Those two are equal and the arc marks are equal. But we're going to ignore the arcs for number 13. What do you notice to find WY, or sorry, W? What do we notice we'll have to do? Anything in particular about this that you notice? Do you notice anything? It has a right angle and it's a right triangle, like that. Bingo! Pythagorean theorem. Okay, a squared plus b squared equals c squared. Which side is c? 13. Okay. Okay, go ahead and solve for your unknown length. Guess what? There's more Unit 8 stuff. Number 14 uses Unit 8 stuff too. Yep, I got that too. 144, and then the square root of that gets us 12. So VW would be what? 24. Because you have to double it. Okay. So let's look at measure of YW. So YW is this arc, and it intercepts angle X. So if I find angle X, I can find that arc. And guess what? We can find X. So we want to know this angle. We have 5, 13, and now 12. We're going to use SOHCAHTOA. Which one do you want to use? Which two sides do you want to use? 5 and 13? Okay. I love that we're using the two sides that they gave us. It really doesn't matter. 5 is our adjacent and 13 is our hypotenuse. So which function? I'm writing all of them so we can look. Which one uses AH? Cosine. Okay. Because we're looking for an angle, we're not using just regular cosine, we're using cos inverse. What over what? 5 over 13. You could have done 12 and 5, but we chose to ignore that one. We chose not to use 12. So in your calculator, make sure in degrees. I get 67 point, what do you want to round to? The 10th, so 67.4. That's a 3/8 degrees. Love that.